All right, so I'm going to give you guys a little video here, hopefully to help you with solving systems by substitution. This is problem number 1. This is specifically for 7th period at this moment, but some of the other classes will be doing this. Okay, so problem number 1 is y equals x plus 2, and the second equation is 5x minus 4y equals negative 3. Okay, so we're going to write a new equation by replacing the y in the second equation with the x plus 2, because that's basically what we're doing when we use substitution. And you got to bear with me here because I'm trying to type and talk at the same time, so if I make a mistake, you'll see me fix the mistake. Okay, so when I make this new equation, I'm going to start by writing, or typing in this case, 5x minus the 4. Instead of the y, I'm going to replace that with x plus 2. And then I'm going to continue typing out, or writing in your case, what's left in this equation here. Okay, my next step is to do distributive property. So I got negative 4 times x, and a negative 4 plus the 2, so that's minus 8. And then I'm just going to keep typing here until I get the rest of that taken care of. Okay, so if you look, the only thing I've done so far is I've taken this x plus 2 and I've replaced it where the y is. Then I did the distributive property. So I've got 5x minus 4 minus 8 equals negative 3. So then the next thing I'm going to do is I'm going to clean that up a little bit. 5x minus 4x is 1x. Okay, and that leaves me 1x minus 8 equals a negative 3. Okay, and then I'm going to add 8 on both sides. Okay, so again, this is a two-step equation. I'm going to try to make it look as much like an equation as possible here. Okay, so we're going to have 1x. Negative 8 plus 8 cancels out, which leaves us with the negative 3 plus 8, which is 5. Okay, so we got 1x equals 5. So basically that is x equals 5. Okay, but we're not done here. So we know that x equals 5. We're then going to take this value and we're going to go back and look at either one of these equations. So I'm going to use the top equation. My top equation is y equals x plus 2. Well, I know now that y is 5, so I'm going to replace that x with the 5. As you can tell, I'm over the capitalized lowercase. Hopefully you guys understand y is y, capital or not. So now I've got y equals 7. So my solution to the very first problem here is 5, 7. What this would look like on a graph would be two intersecting lines where they intersect precisely at the 5, 7. So this is problem number 1. Hopefully that helps with you. And then I'm going to skip down to problem number 7. I'll actually take the time to write this one out. We got 7. We got y equals 2x plus 3. And then we also have y equals negative 2x plus 15. Okay, let's see if I can line these up here. Okay. So in this case, the y's are both equal to something. So y is equal to the 2x plus 3. And then on the bottom one, y is also equal to negative 2x plus 15. So when you run across a problem like this, you're going to still write that new equation, but it's just going to be a little bit different. And it looks like this. We're now going to take the 2x plus 3, set it equal to the negative 2x